Okay, so for page 18, title your paper Writing Equations Given the Graph. And so a couple pages ago we were looking at the equations of the graph, and we were drawing the graph itself given the equation. So now we're going to go backwards. This time we're going to be given the graph and we'll be able to write the equation. So depending on the situation that you've been given, the graph that you've been given, you can choose, but typically there is one or two that's better than a better choice than the other one. So let's look at this first graph here, where you can see immediately the intercepts. So intercept form would be good. We can also see the vertex, so vertex form would be good as well. You could put it in standard form. It would make it a little bit tougher, but it would still also work out for you. Now, so first thing we're going to do, for this first one, I'm going to actually use intercept form. And so the intercept form is going to be y is equal to a parentheses x minus p minus x minus q. Remember that p and q are going to be your x-intercepts, and we can see in this particular case those are going to be -1 and 3. So I'm going to replace those with my p and q in my equation. When I do that, I'm left with y is equal to a parentheses x plus 1 x minus 3. And so now I have to find a. If you remember when we were talking about transformations and writing the equation of a graph with transformations, this is the point that we would actually plug in a point from the graph itself. You can plug in any point that you want, just don't put in those x-intercepts, because when you do that it makes your a go away because it turns these into zeros. So those would actually be your bad points. And so when I do that, I'm going to choose 1, 2 in this case. You can plug any point that you want. It could be a y-intercept, but in this case the y-intercept's not very nice. So I'm going to go ahead and plug in the vertex 1, 2. There should be 1 sitting here. I apologize, I didn't put those in my video here, but that's okay. Go ahead and put those ones there for your x's, and then your y would be 2. When you go to solve this, 1 plus 1 is 2. 1 minus 3 is -2, and so we end up with 2 is equal to -4a. And then you would divide both sides by -4, and you end up with a equals -1/2. So the final answer, plugging that a back in, would be y is equal to -1/2 parentheses x plus 1 x minus 3. You could type this into Desmos to check your answer if you like. Now looking at this second equation here, you'll notice that we're given the vertex. We can't see the intercept, so intercept form would not be a good idea here. So I'm going to start with the vertex form, which is y is equal to a parentheses x minus h squared plus k. I'm going to plug in my h and my k, which is my vertex in this case, -1, 3. Afterward, I'm going to simplify, and so I'm left with y is equal to a parentheses x plus 1 squared plus 3. You'll go ahead and plug in a point now. The point can be anything except the vertex. You don't want that a to go away. So in this case, I'm going to use 0, 5, which is the y-intercept. Again, there should be a 5 here. Looks like I used some white out and just didn't fill it back in, so sorry about that. It should say 5 is equal to a parentheses 0 plus 1 squared plus 3. When you evaluate that, you end up with 5 is equal to a plus 3, which means that a must be equal to 2. You plug that back into your vertex form that you came up with in the beginning, and your final answer is y is equal to 2 parentheses x plus 1 squared plus 3. I always suggest using Desmos to check these just to be sure you got the right answer, just so that you know that you're for sure on the right track. Okay, and that's it for this page.